I'm Chemical Charlie.
And I'm Pie Guy Pepin.
And we're going to do a little experiment with two pennies. One is an old penny,
1979.
And the other one is more modern. It's
1998.
And we're going to just scratch them a little bit with a file. And let's see what happens when we put them in acid solutions.
Ever since 1982, pennies have been made copper as an outer coating, but zinc on the inside. Prior to that, they were made with pure copper. So zinc can actually react with hydrochloric acid, and it will produce hydrogen gas and zinc chloride.
Okay, so let's see what happens. The next step, we're going to put these in a beaker and then add pool hydrochloric acid, which is pretty concentrated, to both of them.
And
we'll see what we observe. All right.
You'll also notice that these are rusted and not shiny pennies, and this is because the hydrochloric acid can actually shine the pennies as well.
Okay, I've got some hydrochloric acid, and it's 31.5%. So I'm going to pour some into this beaker. And now we're going to drop the two pennies in. They are shiny.
And you can see the hydrogen gas being given off by the one that is made out of copper and zinc.
Bubbles form on the surface of the penny, but it's not the copper that's reacting, it's the zinc, all right?
Okay, the reaction has been going for quite a few hours and it's going pretty quickly. So we're going to leave it overnight and see what happens.
Okay, it's the next morning and we see that the penny that had the zinc in it is floating. I'm going to give you a side view.
You can see the penny is floating. The other one is
at the bottom.
We can also see that the substance has turned yellow, but that is not related to this reaction.
As far as we know, it could be chlorine. We're going to dilute it so that
and the penny that is one of the pennies has fallen out. This is the one without the zinc in the middle, and as we can see, it is very flexible. This one is just a regular penny. This is the activity series for the metals, and as you can see, zinc is more active than copper.
Zinc is also more active than hydrogen, meaning that it has a greater tendency to get oxidized to zinc plus 2 than hydrogen does to get oxidized to H plus. On the other hand, copper has a lower tendency to get oxidized to Cu2 plus than hydrogen does to get oxidized to H plus. So here, of the two possible reactions that could take place, what do we know, Pie Guy?
Since zinc is more active than hydrogen, it replaces hydrogen in hydrogen chloride, creating zinc chloride and hydrogen gas. But copper cannot replace hydrogen because it is less active, so there is no reaction.
Okay. And again, these are two examples of single displacement reactions, one that actually takes place and one that doesn't. And we saw this in the demonstration that we gave you. So I hope that makes it clear, and we'll see you next time.